Hello, in this video we're going to go through learning target 424 and 434. The 2.0 level is explaining if something's independent or dependent, and the 3.0 is actually calculating that probability. So the first thing we need to do is define independent and dependent events. So independent events happen without affecting another event. So they're just like completely separate ideas. One of them does not affect the other one. And then dependent is an event that changes based on another. So this one, those things do change based on the situation, the previous or simultaneous event. And once we see some examples, this will become clear, but this is a good definition. Now, looking at our examples, the 2.0 level is simply determining whether or not something is independent or dependent. So remember, independent is just like not related at all. Dependent would change the outcome. So this first one is spinning a 4, then another 4 on a spinner. So if you think of a spinner, if I spin a 4, stop, and then spin another 4, those are not related to each other. The first one, getting a 4, does not change the outcome of the second one. So these are independent. Next one, flipping a coin. Whatever you get on your first flip does not change the second one. So this is also independent. So flipping 10 heads in a row, not dependent on the previous one. Next one, choosing a diamond, keeping the card out, then choosing a club. This one is where we get into a dependent situation. So when you take a diamond, you then keep the card out, you're going to change the outcome of the next one. So instead of having 52 cards, we now only have 51 because we kept that card out. So this is dependent on the outcome of the first. This one, drawing a 2 from the deck of cards, putting it back, then drawing a 5. When you put a card back, it is no longer dependent. So you still have 52 cards for the first one and 52 cards for the second one. These are independent. Next one, Miss Johnson's name being drawn for a prize, keeping her out, then drawing Miss Klefke. The fact that we're keeping me out after the prize means that this is dependent. So there are fewer names in the drawing after mine is gone. And last one, choosing a white sock from your drawer and then choosing another white sock from the drawer. If you're choosing socks, you're assuming you're keeping them out so you can wear them. So this is dependent as well. Keeping something out or replacing it is going to be really helpful to determine independent or dependent. So why don't you go ahead and you try these 6 scenarios, just write I or D, and then push play when you are ready to see the answers. Most of these are independent. As you can see, there's 4 independent over here, and then these 2 are dependent because you're keeping something out once you choose it. Now let's look at how to actually calculate these probabilities. And it's a little different depending on if it's independent or dependent, but not much. So independent events, you find the probability of the events by multiplying the probability of each. So probability of A, that's the first event, multiplied by probability of B. This symbol is new. This is called the intersection symbol. And the intersection of A and B we can think of as and. So like the probability of A and B happening, both of them, is this. Now, similar equation for dependent, except instead of multiplying your probability of A times your probability of B, you're going to do the probability of B given that A has occurred. So like A has already happened. We want to find the probability of B given A, which we did in our last learning target. So let's look at an example of this kind of probability. We have some examples on the back. So find each probability. First one is spinning red, then green, then a 1 on the spinner. Spinners are typically independent because it's not like you're taking a pie slice out every time you spin. So all we're going to do is multiply each of these, and I'm just going to label this as event A, event B, and event C. So the probability of A is red. There are 2 reds on my spinner out of 8 total. You can change these to decimal if you want or leave them as a fraction, up to you. Probability of B is the greens, and there are 3 greens. And then probability of C, which are 1s, and there are 4 1s. So to find the probability of all of these, probability of A intersect with B, intersect with C, we want to multiply all of these together. So 2 8ths, 3 8ths, and 4 8ths. If you change them to a decimal, you just multiply all the decimals, but I'm just going to type them in as fractions. And we get approximately 4.7%. All right, next one, selecting a diamond, keeping it out, then selecting another diamond from a deck of cards. The keeping it out part, that means it's going to be dependent. So to find these, we just want to multiply our A and then B given that A has already occurred. So the probability of A, selecting a diamond, there are 13 diamonds in a deck, so 13 over 52, or 1/4. Then, since we kept that one out, selecting another diamond, our probability of B, given that A has already occurred, well, we had 13 diamonds, but we took one out, so now we only have 12. And then I did have 52 cards, but again, I lost one, so it's 51. So 12 out of 51. And again, to find our probability of A intersect B, we want to multiply our two probabilities. Oops, there's a 0 in there randomly. And we get 5.9%. So whenever you have a dependent one, all you really have to do is make sure that you change your scenario according to A already happening, and then you'll be good. So once you pause it, do the U-tries, and then push play when you're ready to see the answer. All right, so here we go. In this one, this is independent because the first card is replaced, so they're independent of each other. So there's 4 ace cards out of 52, and then same thing for the second one because you put the card back. This one we are not replacing, so this is dependent. So the first one is that there are 3 out of 9 and then 1 out of 8 because we got rid of a marble. So we should have these as your answers. Hope this helps.